In this video, I will continue to demonstrate how we solve rational equations such as these. I'm going to go ahead and spread problem number 5 out a little bit. So I have 3 over x. All right, let me give this problem a little bit more space. And I have 2 over x plus 1. Let me give it a little bit more space. Equals 23 over, and I'm going to go ahead and factor out the GCF, so that's going to be x times x plus 1. So the key to solving rational equations is making all of the denominators the same. Well, this denominator has an x, but the other denominator has an x plus 1. So that means I have to give the first denominator an x plus 1. But I have to put it in the numerator as well. Now, the first denominator has an x. The second denominator does not. So I'm going to have to give it the x that it's missing, and I have to put it in the numerator as well. The third denominator already has both x and x plus 1, so it needs nothing. Once you have like denominators, you can cancel out the denominators and still have a valid equation. I'm going to go ahead and do the distributive property now. So that's going to give me 3x plus 3 plus 2x is equal to 23. Okay, combining like terms, I'm going to get 5x plus 3 is equal to 23. If I subtract 3 from both sides, I get 5x is equal to 20. But then I could divide both sides by 5. And that would give me x equals 4. But I need to look through real quick, make sure that this will not cause a 0 denominator and thus be extraneous. The number 4 will not cause a 0 denominator. So this is the solution to number 5. All right, I'm going to go ahead and spread out number 6 a little bit. So I have 4 over x plus 2. X minus 2. Okay, minus 2 over x is equal to 14 over, and I'm going to pull out the GCF here, so this is going to be x times x minus 2. Okay, I need like denominators, folks. So the second denominator has an x, so I'll have to give this one an x in the numerator and the denominator. Since the first denominator has x minus 2, I'm going to have to put x minus 2 in the numerator and the denominator. The third denominator has both x and x minus 2, so it needs nothing. But once I have all the denominators the same, I can cancel them out. So that's going to leave me with 4x. Now be careful. You know what, maybe I'll just copy this down. So I have 4x minus 2 times x minus 2. Normally I do the distributive property now, but there's something I want to make extra clear. When I do the distributive property, I'm distributing a negative 2, not a positive 2. So that's why I'm going to have 4x and then minus 2x plus 4. So a common mistake is just to put minus 4. If you just did 2 times negative 2, you would put a negative 4, and that would be wrong. You must distribute a negative 2. Anyway, combining these like terms is going to give me 2x plus 4 is equal to 14. And then if I subtract 4 from both sides, so I have 2x is equal to 10. If you divide both sides by 2, you get x is equal to 5. A quick glance will tell you that it's fine for x to be 5. That will not cause a 0 denominator. It's not extraneous. Again, I like to spread these problems out a little bit to give myself some space. All right, a little space to maneuver. Okay, let's see what happens. Of course, we need like denominators. So I see an x over there, so this is going to need an x for sure. All right, in the numerator and the denominator. But I also see a 20. So I'm going to have to slap a 20 up in here in the numerator and the denominator. All right, big numbers. This one has an x, but it's going to need the x plus 1 in the numerator and the denominator. And it's going to need this big fat 20 in the numerator and the denominator. Now, the third fraction has the 20. It needs the x and the x plus 1. Okay, in the numerator and the denominator. So now that I have like denominators, I can cancel them out. Okay, so we have to be a little bit careful with how we handle this. So first I've got 20 x squared, because x times x. Now, for a minute here, I'm going to leave this negative 20 because I need to multiply these two together. Now, I recognize this as the difference of two squares. I know this is going to be x squared minus 1 because think about it. If I factored this, x squared minus 1 always factors as x plus 1, x minus 1. And that's what I have. Or you could just sit here and just multiply it out, you know, FOIL it, double distribute, whatever you want to call it. The middle terms cancel out, and negative 1 times 1 is negative 1. Either way, you get x squared minus 1. And this is going to equal this numerator. And I am going to go ahead and distribute here. So that's going to give me x squared plus x. All right, so now I'm going to distribute this 20, but it's really a negative 20, so be careful. The negative goes with it. I'm distributing a negative 20. So now I'm going to have 20x squared minus 20x squared plus 20. All right, that's the big mistake I'll see students put minus 20. Negative 20 times negative 1 is positive 20. Is equal to x squared plus x. Now I need to get all these on, well, let's combine like terms first. So, well, look at this right here. We have 20x squared and a minus 20x squared. These are going to just cancel each other out, like right away. Okay, so that's going to leave me with 20 is equal to x squared plus x. Now, what if I subtract 20 from both sides? Can you see that I'm going to get 0 is equal to x squared plus x minus 20. All right, this is probably factorable. Okay, x squared is x times x. 20. 20 is either 4 times 5 or 2 times 10 or 1 times 20. Considering that I need the middle to be 1x, the 4 times 5 option is looking pretty good. So if I do 4 times 5, I know inner plus outer must equal middle. Inner, I have 4x. Outer, I have 5x. To get a middle of 1x, I need a -4 and a +5. That would make 1. So there's my -4 and there's my +5. I need to check one last thing. Do I get -20? Well, -4 times +5 is -20. So this is the correct factorization. So now I can set each of these factors equal to 0. So that's going to give me x equals 4 and x equals -5. All right, I'll just do a quick check to make sure that none of those are extraneous. Nope, these are both fine. None of these cause a 0 denominator. So these are the solutions to problem number 7. All right, as usual, I'm going to spread these out a little bit. So I have 6 over x minus 3, and then minus 4 over x plus 2, and then equals 12 over. Good morning. Looking at the first fraction, I see the next denominator over has an x plus 2 in there, so I'm going to need an x plus 2. All right, have to put it in the numerator and the denominator. Since the first fraction has an x minus 3, the second fraction is going to need an x minus 3 in the numerator and the denominator. The third fraction has both the x minus 3 and the x plus 2, so it doesn't need anything. Once you have all three denominators the same, you can cancel out those denominators. So now what I have is 6 times x plus 2 minus 4 times x minus 3 is equal to 12. So I do the distributive property. All right, take care to distribute -4, not +4. So this will be 6x plus 12 minus 4x plus 12. -4 times -3 is +12 is equal to 12. Combining like terms. So the 6x and the -4x, those are like terms. And the 12x and another 12x, those are like terms. So if I put those together, I'm going to get 2x plus 24 is equal to 12. Okay, so let us subtract 24 from both sides. So that's going to give me 2x is equal to -12. And then when I divide both sides by 2, that's going to give me x is equal to -6. And then I just have to make sure this is not extraneous. Let's see, 3, -2, those are the illegal values. -6 is okay. All right, here's number 9. I've just spread the terms out so I have room to add in some different things. In fact, I'm just going to go ahead and put a nice denominator, well, a nice fraction bar right there underneath the 3, no big deal. So I look over to the right, I see that this fraction has a 2x plus 1 in the denominator. I need all the denominators to be the same, so I know that this first fraction will need a 2x plus 1. We're going to have to put it in the numerator as well. So 2x plus 1 right here. Since the first fraction has an x minus 2, the second fraction will also need an x minus 2. Okay. Now the third fraction needs both of these. So I will just copy that down. 2x plus 1 times x minus 2. All right, 2x plus 1 times x minus 2. Once you have like denominators, you can cancel them out and still have a valid equation. So, I'm going to go ahead and multiply these together. You can think of this as doing the distributive property twice or foiling it. But I'm going to do half of it in my head. So x times 2x is 2x squared. Now, inner and outer, that's how I think about this. Inner, I have negative 2x. Outer, I have positive 1x. Negative 2 and positive 1, that makes negative 1. So I have negative 1x. And then negative 1 times positive 1 is negative 1. Okay, boom. That's the first one. Okay, now here comes this pair of binomials. So 3x times x is 3x squared. Now inner and outer. Inner I have 6x. Outer, okay, I'm multiplying now. That's negative 6x. Well, guess what? 6x and negative 6x cancel each other out. So I won't write down anything. And then I have 6 times negative 2 is negative 12. So I'll write that down. Okay, and then I have to bring down this 3. I'm just going to have to keep that out front for another step. So if I multiply this together, I'm going to have, let's see, so 2x times x is 2x squared. Inner, I have 1x. Outer, I have negative 4x. I'm multiplying. So I have inner is 1x, outer is negative 4x. Together, that makes negative 3x. And then 1 times negative 2 is negative 2. So I've got this. So on the left side, I might as well go ahead and combine some like terms. So I see the 2x squared and the 3x squared. Those are like terms. In addition to that, I've got negative 1 and negative 12. Those are like terms. So if I put that together, I'm going to have 5x squared. And I'll just bring down this negative x. And then I have negative 13 is equal to. Now over here it's time to do the distributive property. So that's going to make 6x squared minus 9x minus 6. All right, now it's time to get all of this on one side of the equation. So I choose to subtract 5x squared from both sides instead of subtracting the 6 because I want my x squared term to be positive. If I do it this way, I'll get a positive x squared. So that means I have to get rid of all of this. So I'm going to add x to both sides, and I'm going to add 13 to both sides. So that's going to give me 0 is equal to x squared minus 8x plus 7. So this is going to factor down. Okay, x times x, 7 times 1, negative times negative. Negative 7 and negative 1 will give me negative 8. Negative 7 times negative 1 gives me positive 7. Anyway, if I set each of these equal to 0, that's going to give me x equals 7 and x equals 1. All right, number 10 has this strange backwards term. We're going to have to deal with that. So just remember, as I do this off to the side. If I have 4 minus a, if I write this the correct order, it'll be negative a plus 4. But I could take the negative sign outside of the parentheses like a GCF, and that's going to leave behind a minus 4. Because think about it, if I distributed the minus sign, that would turn this back into negative a plus 4 again. So it must be equivalent. So this is the form I'm going to use. So when I recopy this problem, instead of 4 minus a, I'm going to put negative parentheses a minus 4. In fact, maybe I'll just squeeze it on right now. Negative parentheses a minus 4. Okay, so anytime you see a backwards term, make that substitution. Now, there's one more thing I'm going to do right now. Because this is subtraction, I now have minus a negative. When you have minus a negative, that is a positive. So it's really just going to be plus. Okay, so with that, I can now go ahead and do the problem. So I have 2 over a plus 3. Okay, plus 3 over a minus 4 equals 2a minus 2 over, let's see, a squared is a times a. 12 is 3 times 4, 2 times 6, or 1 times 12. Considering that the middle term is 1a, I'm betting 3 times 4 is going to be the best choice. So I will factor the 12 as 3 times 4. Inner plus outer must equal middle. Inner, I've got 3a. Outer, I've got 4a. I'm trying to get negative 1 middle. So for that, I need a positive 3 and a negative 4. So that's why this will be positive and this will be negative. Now I have to check one last thing. Am I getting negative 12? Well, positive 3 times negative 4 is negative 12, so we're good. So everything is factored correctly. Time to make the denominators all be the same. Well, I look over here, I see a minus 4. That means this side is going to need an a minus 4 in the numerator and the denominator. The first fraction has an a plus 3. So that means I need an a plus 3. Numerator, denominator. The next fraction already has a plus 3 and a minus 4. So it doesn't need anything. So I can go ahead and cancel these out once I've made them all the same, and I still have a valid equation. So I'll go ahead and do the distributive property now. So that's going to give me 2a minus 8, plus 3a plus 9 is equal to 2a minus 2. So it looks like we've got some like terms here. Boom and boom, like terms. And also pazzow and pazzow. Okay, so combining like terms will give me 5a plus 1 is equal to 2a minus 2. Now, I need to get these like terms together, so I'm going to go ahead and subtract 2a from both sides. So that's going to give me 3a plus 1 is equal to negative 2. But at this point, I would then subtract 1 from both sides. So that's going to give me 3a is equal to negative 3. To get a by itself, I can divide both sides by 3. And that's going to give me a is equal to negative 1. So I just need to check and make sure this is not extraneous. I see negative 3 is illegal, positive 4 is illegal. This is neither of those, so negative 1 is okay. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.